In this section, we want to learn about the division of radicals and rationalization. Let's do some warm-up problems first. In the first problem, we want to simplify square root of 65 over square root of 5. 65 can be rewritten as 5 times 13, and let's leave square root of 5 in the denominator as it is. When we have multiplication under the radical sign, we can separate them and write it as square root of 5 times square root of 13 over 5. Square root of 5 in the numerator and denominators are the same, so we end up getting square root of 13. Second problem is square root of 48 minus 2 over 10. 48 can be decomposed into 4 squared times 3, and we can write that decomposition as radicand and separate two factors and write it as square root of 4 squared times square root of 3. I said square root of a squared is absolute value of a, so absolute value of 4 is 4. So we write 4 square root of 3. When we have fraction in this way, we can separate the terms. So we can write like this. So square root of 48 over 10 minus 2 over 10. We know that square root of 48 is 4 square root of 3, and we have 10 in the denominator, and we have 2 over 10. 10 is 2 times 5, 4 is 2 times 2, and these two numbers will be cancel each other. 10 is 2 times 5, and 2 on the numerator and denominator will cancel each other. So the numerator will have 2 times square root of 3. So 2 square root of 3 over 5 minus, we have 1 over 5. We can combine those, then it becomes 2 square root of 3 minus 1 over 5. Next one is about rationalizing the denominator. Rationalizing the denominator is the process to remove a radical from the denominator. Important points you have to remember when you do rationalization will be when you multiply the same square root twice, that was under the radical sign. When we have square root of fraction form, we can separate the square root in the numerator and the denominator. Other very important formula is a plus b times a minus b is a squared minus b squared. Let's work with the examples. We want to rationalize the denominator. That means we want to remove the radical sign in the denominator. I said square root of a times square root of a is a. So our strategy will be multiplying the same number in the same radical in the denominator, in the numerator and denominator. Then the denominator will become 5, so we remove the radical sign, and the numerator will be combined to square root of 30. In the second problem, we have square root of 5 over 6. So we want to separate the radical sign to the numerator and the denominator. And then what we want to do is we want to multiply by the same number in the denominator to the numerator and the denominator. By doing so, we can remove the radical sign in the denominator. Denominator became 6 and the numerator became square root of 30. In the following problem, we have 4 over square root of 7x. It doesn't matter whether just numbers written under the radical or under the radical sign, or radicand contains x or some symbolic notation. What's important here we have only one radical in the denominator. Then we just multiply by that radical in the numerator and the denominator. The denominator becomes 7x and the numerator is 4 square root of 7x. The next problem shows the concept of conjugate and how that plays a role. If we multiply the same number appearing in the denominator, then we cannot remove the radical sign. So instead of multiplying by the same number in the denominator, in this case, the number consists of two terms, 3 square root of 2 and minus 1. In that case, we will multiply by its conjugate. That means the connection part changes the sign. It was minus, so we will write as plus. So numerator and denominator will have 3 square root of 2 plus 1. And minus 7 is here. Then in the formula, what I told you was this multiplication in the denominator will be first term squared minus second term squared. And in the numerator, we can do distribution. Then that'll be minus 21 square root of 2 minus 7. 3 square root of 2 squared is 3 square root of 2 times 3 square root of 2. I said 3 square root of 2 is 3 times 3. So we can write reorganized. Then 3 times 3 times square root of 2 times square root of 2. 3 times 3 is 9. And square root of 2 times square root of 2 is 2. So that is 18. So 1 squared is 1. So that is negative 21 square root of 2 minus 7 over the first term's squared is 18 minus 1. And then that is minus 21 square root of 2 minus 7 over 17. Again, what did I use? A plus B times A minus B equals A squared plus B squared. In this situation, what you can say is A square root of B plus B, C times A square root of B minus C is A squared B minus C squared. So this is a real number. This is in it without radical. And I said these two are considered as conjugate.